Hello and welcome to this video. So in this video we're going to have a quick look of the chapter 2. We will going to study chapter 2 and review the main concept in this chapter. So we are learning mechanics in which we in which we study the motion of the objects. So in mechanics we have two heads. First we're going to discuss kinematics and then dynamics. In kinematics we study the motion without the cause. In dynamics we study the motion with cause. So for the chapter 2 and 3 we were in kinematics. We are going to study in kinematics, and from chapter 4 onward we're going to study the dynamics. Okay, so the first concept in this chapter 1, because we're going to study motion along a line in a straight line, actually we are studying the motion in one dimension or a motion in 1D. So the first concept is the position of the particle. So the position of the particle is the coordinate of the particle along the x. So coordinate along the x. So it's, for example, we have this origin O or 0. The position of the particle, for example, over here is x equals to 5. So this is the position of the particle. And if the particle changes its position along the line, at some time it's over here, x equals to 5 meters, and at some point P2 changes its position, its coordinate now become like 7. So it changes its position along the line. So when it changes its position along the line, it means it changes position from point P1 to point P2. It means it changes its coordinate from point P1 to point P2. So position is the coordinate x for a particle. Now, as the particle changes its position from point P1 to point P2, so the change in particle's coordinate, so the change in particle coordinates is its displacement. So the change in coordinate, which is delta x, is x2 minus x1. So this is a displacement. So the time rate of change in particle's position is defined as the average velocity. So the average velocity is defined as x2 minus x1, the change in displacement, and t2 minus t1, which is the change in time. So this is the average velocity. So velocity is a vector quantity and it has unit meter per second. So when the object is changing its position in time continuously, we can plot a trajectory of the particle along graph. We can plot a graph as a function of time, particle position as a function of time, and this graph is known as the position time graph. For example, if the body starts its motion over here at the origin and after some time it has the position at this point, then after some time it has the position at this point, and after some time it has the position at this point. So we can form like this is your origin, this is point P1, point P2, point P3. So at every point it has a distance and it over. So this is position along the y-axis and time on the x-axis. So this is T1, this is T2, T3 and T4. So we can find the particle position or displacement using that graph, and we can find also the velocity or average velocity by using this graphical notation or a curve. So if the particle changes its position particle changes its position between these 2 points, like it's at the trajectory like this, and it changes its position between point P1 to point P2, so the average velocity this is the position x1, this is x2 because it's x, this is t, this is your t1, this is your t2, and this is the change in. So the average velocity is V average is the slope of that curve, which is nothing but x2 minus x1, t2 minus t1. So you can find the average velocity of the object using the position versus time graph or distance versus time graph, using the slope of that curve, selecting any 2 points on the curve. This is your t1, this is your t2, and using the 2-point form like what you do in your calculus. So this is your average velocity. But for every moment in time, if we wanted to find the velocity at every instant of time, your velocity will become instantaneous velocity. Instantaneous velocity, which is the velocity of the object or a particle at a specific instant of time. So along the path. So we wanted to find at any instant of time, then your time interval, which is delta t, become very small and it reaches to, like, it approaches to 0. Then your average velocity will become an instantaneous velocity, and it's the limiting case. Delta t tends to 0. Delta x divided by delta t. Delta x is your x2 minus x1, and delta t is your t2 minus t1. So we have this is the definition of the derivative, which is dx by dt. So this is your instantaneous velocity. How do you find your instantaneous velocity? Using the curve or a graph of position versus time. So you have to draw at that point tangent to that line, tangent to that curve, and this tangent will give you the average instantaneous velocity. So V instantaneous you can get using tangent to the curve. Okay, so this is one method we can get an average velocity and instantaneous velocity using the graphical method. So we can find average velocity and instantaneous velocity using the graphical method. So we can find average velocity by taking slope of the curve, which is nothing but the x2 minus x1, t2 minus t1, and we can find instantaneous velocity at every moment in time at a specific instant is just by taking tangent to the curve, and it's dx by dt. Okay, now we're going to discuss what is the difference between distance and displacement. So what is the difference between distance and displacement? For example, if we wanted to go from point A to point B, we can go in a straight line meeting at point B, or we can take a path so the shortest distance between 2 points along the line, shortest distance between the 2 points, which is from A to B, is your displacement. Shortest distance along a straight line, and the length of the path, which is I have had covered from A to B, reaching at B, is the length of the path is your distance. So distance is a scalar quantity while your displacement is a vector quantity. Both have the units meters, so both are measured in meters, but this is a scalar quantity and this is a vector quantity. So similarly, we have speed and velocity. So speed and velocity, so speed like distance is a change in distance, so is the distance, or speed is defined as speed is the total distance covered divided by the total time. So speed is a scalar quantity, and its unit is meter per second, while velocity is the rate of change of displacement, and it's a vector quantity, and its unit is meter per second as well. We can find speed if we know the velocity. So v speed is nothing but taking the magnitude of the velocity. So speed is just the magnitude of the velocity. So we can find the velocity or average velocity by two methods. One is a graphical method, and one if it's a function method, which is we call a function. If you are given by a function of t, function of x function as a function of time, so we learn that we can find average velocity using the graphical method, which is the slope of a curve, and we can find instantaneous velocity using the tangent to a curve. But if we are given by a function like this function is given like this, x of t is minus 4t plus 2t square. So we wanted to find the average velocity, v average, and we wanted to find v instantaneous velocity. Whenever you wanted to find the average velocity, remember that it should be an interval. So the interval is given t equals to 0 to t equals to 2 seconds. Okay, and instantaneous velocity will always be calculated at particular instant of time. So only the time interval is given, not the time interval, but only the time at which we wanted to calculate. So if you are given by a function, you just calculate the position at every instant of time. So what is the position of this at t equals to 0? So t equals to 0, when we put t equals to 0 over here, it's 0, it's t over there. So minus 40 plus 20 squared equals to 0. So this will become your x1. So what's your x2, or x equals to 2 seconds, you put t equals to 2. So 2 square 4 multiplied by 2 8. So we get 4 multiplied by 2 minus 8, it's 0 as well. At 2 seconds it's also 0 as well. Okay, then we can find v average is nothing but x2 minus x1 divided by t2 minus t1. In that case your x2 is 0, your x1 is 0 as well, t2 is 2, and t1 is 0. So your average velocity is, we can find the instantaneous velocity. V instantaneous is nothing but dx by dt, taking the first time derivative. So what is the time derivative? Is minus 4. T has one derivative. Then you take the power rule. So 2 multiplied by 2, 4 t. So what you wanted to find instantaneous velocity at t equals to 2 seconds. So just put over here v instantaneous dx over dt is minus 4 plus 4 into 2 is 8 minus 4, which is 4 meter per second. So at 2 seconds its velocity is 4 meter per second, but over the interval between t0 and t2 second its velocity is 0 meter per second. Okay, so this is how we can find the average velocity and instantaneous velocity by a graphical method. You need to take a slope, and you take a slope between 2 points, x2 minus x1, t2 minus t1. Okay, and then take a tangent to any curve like this. This is a curve, and you want to find out at this point. So you take a tangent. Okay, take a tangent, take at point P. Okay, so this is how you can find the average velocity, v instantaneous velocity using the graphical method and using the function method. If you are given by a function, just calculated the x2 minus x1 at time t equals to 0 or t any time, and for instantaneous velocity just calculate the first time derivative and put the value of t. In that case your t is 2 seconds. So velocity is 4 meter per second. Okay, now we will going to discuss the acceleration. Acceleration is the time rate of change of velocity. So the average acceleration V average is defined as the change in velocity time. So this change in velocity is nothing but v2 minus v1, t2 minus t1. So this is your average acceleration. So acceleration is the time rate of change of velocity. Acceleration is also a vector quantity. And its SI unit is meter per second squared. So this is your average acceleration. But the instantaneous acceleration is defined as the acceleration of the body at any specific instant. Like what we did in the velocity section. So a instantaneous is defined as limit delta t tends to 0 del v over del t, which is nothing but dv dt. So this is your average instantaneous acceleration at every moment in time. Okay, like what we did, we can plot the position of the particle as a function of time, now we can plot the velocity of a particle at any instant of time, and this is your speed time graph or velocity time graph. Velocity type graph. So if the object is moving like this, so the speed time graph, so this is your time, which is independent, this is your speed or velocity, which is at y-axis. So we can find the average acceleration. You can find the average acceleration just like what we did in the velocity section, is just by taking the slope of velocity time graph. And how do we take the slope? We select 2 points on a curve. This is our point V1, this is our point V2, this is your point T1, this is your point T2. So your slope is nothing but 2-point form, which is x2 minus x1, t2 minus t1. So this is your average velocity, average acceleration. Similarly, if we wanted to calculate the instantaneous acceleration, instantaneous, so how do we calculate? We, like what we did in the velocity section, so we take a tangent to that point, which is the tangent to the curve, and at point P, at any point we can take a tangent to that curve. It will give you the instantaneous acceleration. Similarly, like what we did in the velocity section, we can find the acceleration by two methods as well. One is graphical method and one by a function method. If v is a function of t is given to you, or it may be given to a function of x is a function of t. So you know that your average acceleration is nothing but v2 minus v1, t2 minus t1. Okay, so your velocity, which is your average velocity, is just but x2 minus x1, t2 minus t1. So you calculate velocity first from the position function, and then you substitute velocity at different time, then you calculate the average acceleration, and you can calculate your instantaneous acceleration is just d by dt v, and you know that v instantaneous is d by dt x is nothing but d2x dt. So this is how we find the instantaneous acceleration. Okay, now we're going to discuss the motion under the constant acceleration. Motion under the constant acceleration. For example, you have a table and a book lying on the table. book lying on the table. So the book is not changing its position with respect to time. It means is at rest. When it's at rest, its acceleration is 0. So the acceleration versus or velocity versus time graph of this situation, velocity versus time graph of this situation, Vx, Vt. So object is this acceleration or 0 acceleration, so it will remain over here. It doesn't change its position. So this is the situation when the object is at rest and its slope is 0. Its slope is 0, which means if slope is 0, velocity time graph as a slope is 0, which means acceleration is 0. So this is the velocity time graph when the object at rest. So what if the object is moving with a constant velocity, constant speed? So if the object is moving the constant speed, constant velocity, it means it's moving uniformly. It covers equal distance in equal interval of time. So it has a graph, straight line. Oh, sorry. Like that. So this is your time axis. This is your velocity axis, and the slope of this line is this area under the curve. And it looks like a triangle, so it's you can calculate its area. So this is the graph of straight line when the object is moving with constant speed or uniform speed. So when the object is not moving with constant speed and it's accelerating, so this graph will look like this. When the object is moving with non-uniform speed. Okay, so it's not a straight line, it's a curvature. So under the constant acceleration, so we average along x will become ax, and we define our average acceleration, which is v2x along x minus v1x divided by t2 minus t1. When we start our motion, we start from the origin. We start over the origin, time t equals to 0. Okay, so we select time t1 equals to 0, and time t2 we take at any time after which we observe the motion, which is time t. And when we start our motion, it has some initial velocity. We define our initial velocity v1, which is v naught of x, which is v1, and then v2 is your vx, your final velocity. This is your initial velocity, and this is your final velocity. So your average acceleration along x under the constant acceleration is vx minus v naught of x over t. So just multiply both sides by t. So you will get ax, which is vx minus v naught of x into t. So your final velocity is equals to, we take this over here, so vx plus at. So this is your equation of motion, first equation of motion. So we define our average velocity along the x, which is x2 minus x1, t2 minus t1, and the average velocity along the x when the acceleration is constant is defined as v1 plus v2 divided by 2. This is only valid when the acceleration is constant. Only valid when the acceleration is constant. And we defined prior that our initial velocity is v naught of x, which is v1. Final velocity is vx, which is v2. Our time t1 we start with 0, and time t2 is t. So these two have the average velocity. We equate this. This is your x2 is your position x, x1 is your initial position x naught. So when we equate these two equations, we become the equation become x minus x naught divided by t minus t0, which is t, equals to v1 is v naught of x, v2 is the final velocity vx divided by 2. So when we multiply this equation by 2, we get 2 over t x minus x naught equals to v naught of x plus vx. And from equation number 1, we know that vx is nothing but this. So we substitute this. So x minus x naught 2 t equals to v naught of x plus v naught of x plus axt. So we get 2 v naught of x plus axt, which is 2 x minus x naught over t. So when we divide this 2 on both sides, so we get x minus x naught over t v naught of x plus axt over 2. And when we multiply t on both sides, so we get this t, we cancel out, x minus x naught equals to v naught of xt plus 1/2 axt squared. So this is our second equation of motion. Now we're going to eliminate t in this equation, so we will get the third equation of motion. So if we see our first equation, which is vx naught, Vx is v naught of x plus axt. So if we find t is nothing but v naught of x minus t is vx minus v naught of x over a. So we substitute this value of t in equation number 2. So we get x minus x naught is equals to v naught of x, and t has a value vx minus v naught of x over ax plus 1/2 ax, and t has a value vx minus v naught of x over ax squared. So we multiply this, we get v naught of x vx, this v naught of x becomes v naught of x squared over ax plus 1/2. This is a square as well, this is a square, this will become a square due to this 2 over here. So we get ax vx minus v naught of x whole square over ax squared. So this one ax will be cancelled out, x minus x naught, we left with v naught of x vx minus v naught squared x plus 1/2 vx minus v naught of x squared over ax. So here we can open the formula a minus b whole square, a minus b whole square, which is a square plus b square minus 2ab, and both have ax common. So we can take an LCM, or can take this common as well. So we get 2ax, and we multiply this by 2, this factor by 2, so 2 v naught of x vx minus v naught of x squared plus we open the formula a minus b squared, which is a square minus b squared plus b squared minus 2ab. It's not, so we get 2 v naught of x vx minus 2 v naught of x squared plus vx squared v naught of x squared minus 2 v naught of x vx. This 2 v naught of x, will be cancelled out, and we have minus 2 v naught of x squared and plus v naught of x squared. So we left with this vx squared minus v naught of x squared over 2ax. So 2ax x minus x naught, which is vx squared, take this over here or multiply with the both sides. So this is your equation number 3, which is our third equation of motion. Okay, so this is the motion under the constant acceleration, and we derive this 3 equation of motion. Now we further discuss the motion which is free fall. So motion free fall. So when the object move under the action of gravity, this object this motion is known as free fall. So object move under the action of gravity is free fall. So if I drop this object, it will go like this under the action of gravity, and it hits the ground. After some time, this motion is under the action of gravity, and gravity is a force, and there is an acceleration which is called the gravitational acceleration, which is constant 9.81 meter per second squared. So the direction of this motion is always toward the center of the earth, or downward direction. Okay, if the object is dropped from here, so it falls under the action of gravity, so that's why its motion is free fall. So when the object is dropped from certain height or released from rest, its vyi, which is the initial y component of the initial velocity, is 0. When the object is thrown upward, your ax will be negative g, upward motion, and your ax will be positive g if the motion is downward. Downward means toward the center or towards the earth. So when the object is thrown upward, its vyi is positive, and when object is thrown downward, then its vyi is downward, vyi is negative. Positive and negative. So under the action of gravity, your equations of motion will take the form, your first equation of motion take the form Vx becomes like Vy, or you can have Vy is V naught of y plus gt. Your acceleration will become the gravitational. Your equation will be like Vx, V naught of x, axt. So this will become Vy, its motion along the y. This is V naught of y, and then this ax will become g. Then your second equation will become y minus y naught is V naught of y t plus 1/2 gt squared. And your third equation of motion will become a g y minus y naught vy square minus v naught of y squared. So these are your three equations of motion under free fall. So now we're going to solve some problem on that. So we will see you in the next video with some tutorial of chapter number 2. So see you in the next video. Thank you.